Very good morning, students. Now we are going to see the first topic of the second chapter, and the topic is electric potential due to a point charge. So, before telling you this derivation, I want to discuss a definition of electric potential with you all. You all must be knowing what is electric potential. Electric potential, which is denoted by the letter V, is actually defined as the work required to bring a unit positive charge from infinity to a point. So this is the formula for potential, that is work upon charge. So using this formula we are going to find the potential due to any charge. So we are finding the electric potential due to a point charge plus Q, which is placed at a point O. You can see this is a positive charge placed at a point O, and we are finding its potential at point P. That is, what will be the potential at point P due to this plus Q charge. So for that, let us imagine a test charge that is Q0 at point A, which is at a distance x from this O. The distance of point A from the plus Q charge is x. So by Coulomb's law, we know that from Coulomb's law, the force experienced by this QO charge due to this plus Q charge is given by this formula, that is 1 by 4 pi epsilon 0 into Q0 by x square, because the distance between these two charges is x. So now the small work in moving this test charge from the point, the small work in moving the test charge from point A to point B. If you are moving this charge from here, from point A to point B, and the distance between the point A and B is dx, then that work is given by the dot product of f dx. This we know, dot product of f dx, and in this case theta, this is because f dot product is f dx cos theta, and in this case theta would be 180 degree, because both are positive charge. The force exerted on Q naught due to this plus Q charge will be repulsive force. That is, the direction of force will be repulsive. As you can see here, force is in this direction, it is in this direction, while the displacement is in this direction, so both are opposite to each other. That is why theta is 180 degree, or we can write this equal to minus f dx. This is the small work done. But if we want to find the total work done in moving that charge from infinity to that point P, point P is at a distance, you can see that point P is at a distance r. So from infinity to point P means from infinity to r. So that work will be given by the integration of this dw, which we have just found out, and it is equal to minus f dx, and limit will be from infinity to r. This is the total amount of work done. And on keeping the value of f here, we will get this expression. Again, on putting the limit, since 1 by 4 pi epsilon 0 into q naught will come out of the integration, we will do the integration of only 1 by x square, which is x raised to minus 2, and that integration would be minus 1 by x. You all must be knowing how to do the integration of x raised to minus 2. It will be x minus 2 plus 1 upon 2 minus 2 plus 1, and this will be minus 1 by x. This can be written as minus 1 by x. And on putting the limit, how do we put the limit? That is upper limit minus lower limit. So it will be minus 1 by r, but already minus sign is outside, so we can just change the order here and remove the negative sign from here. On removing the negative sign, we will write it 1 by r minus 1 by infinity, and this can be further written like this, because 1 by infinity will be 0, this expression will become 0. So we are left with only this, and this is the value of potential. This is the value of work. Actually, this what we have found just now is the work, and we know that potential is work upon charge. So in this case, V equals to W upon Q naught, and here when we're keeping the value of W in this formula, Q naught will get cancelled, so we are left with this expression. So this is the value of potential due to that plus Q charge at a point P. So we have seen that potential, that the value of potential V is inversely proportional to R. It is inversely proportional to R. So this is how we find the potential at any point P at a distance R from the charge.